Apportionment and voting is the last unit for our course, um, Mathematics in the Modern World. So these are the learning outcomes: use mathematical concepts and tools in apportionment and voting, supported the use of mathematics in various aspects and endeavors in life. So in 1920, no apportionment was done because they cannot agree, the Congress cannot agree on the method to use. So they hired some mathematicians to recommend to create something, and they recommended the Huntington. Huntington is the one on the right, and on the left is Hill. So it's a combination of it's a collaborative effort between the two. So they call it Huntington Hill method. So they continue to use Webster's method in 1931, but after a second report recommending Huntington Hill, it was adopted in 1941. So currently, it's the method that's being used in the U.S. Congress. I'm not so sure what the Philippines Congress is using, but anyway, we can investigate further on that. So the Huntington Hill method is similar to Webster's method, but attempts to minimize the percent differences of how many people each representative will represent. So first step is still the same. We will be we'll be finding the divisor. And then next step, we will still have the quota. So the third step is where the start of the uniqueness of Huntington Hill's method. They recommended to have to get the lower quota, which we will call n, and cut off the decimal part of the quota. So and then we compute the square root of n times n plus 1, which is the geometric mean of the lower quota, and on one higher value. So we have now the quota here, and then dropping off all the values because we need to cut off the decimal portions, 7, 24, and 9. But we know that this will not add up to 41. So what the Huntington Hill methods will apply is after computing the lower quota, we moved on to the next step. So it's a bit longer. So it's solving the geometric mean of the lower quota. So our n here, remember earlier, so our n will be our 7. So we solve square root of 7 times 7 plus 1. So that's enclosed inside the radical symbol, and we arrive with 7.48, while the second one is 24 times 24 plus 1. It will give us 24.49, and the last is 9, and then 9 plus 1, that gives us 9.49. So that is how we arrive with a geometric mean. So to get the original allocations, add up the resulting whole numbers. So we look at the resulting whole numbers. We have 7, 25, that's being rounded up again, and we have 9 here. So we run up the quota if the quota is higher than the geometric mean. So if it's higher than the geometric mean, uh, 49. We look at it kinit 24.48, mas dako siya sa mas dako ang 7.48 sa 7.41. So as is, mas dako ang 9.49 kaysa 9.0017. Pero ang sa Newcastle, 24.49 is lower than 24.58. So what they did, the Huntington Hill method suggested to round up the quota if the quota, kini quota, is higher than the geometric means. If higher than any, we add 1, we round up the quota. Okay, so to get the original allocations add up the resulting whole numbers. So we were able to get 41. In case that this will not add up to 41, what will we do? So it is suggested that the divisor is reduced and the quota and allocations are recalculated. So more or less, there's a similarity between the previous methods that were being introduced. Okay, so until such time that you will arrive with the target number of representative here. Okay. So if you have questions and clarifications with any part of this video discussion, drop your questions in the comment section in our group page. So thank you so much and have a good day.